Okay, so this week we're going to continue our exploration of coding a little bit. Last week we kind of started studying the foundation. This week we're going to continue that foundation so we can start adding some really defined functionality inside of our games itself. You know, Indigo and I were talking before class that we're going to be every week we're going to be taking a small little baby step forward. Okay, you know, these ideas are pretty complex. There's a lot of functions that we're creating in the scripts that we're generating. So we're going to take it pretty slow, very slow, as we walk through this. I would really, really encourage you, if you're into this thing, if you're really kind of dedicated to learning at the very least a small amount of functionality when it comes to computer programming, to really dive into the online community. There are a lot of resources out there. The challenge with a lot of these online resources is that they're written for the current skill level of the author of the resource. So if the person that is supplying some code snippets is really super advanced, right, their examples are going to be very super advanced. So at times it can be a big challenge to find the good resources and the good starting points. An excellent starting point for us, especially when it comes to the development side of the game art pipeline, believe it or not, is first-party Unity stuff. Okay, so I've just gone to unity3d.com. If you go to the Learn section, okay, there's a lot of really great stuff in here. And I mean awesome learning resources that will help you figure out how to infuse this next level of interactivity into your game. So under the Tutorials section, they've actually done a couple of really cool things. A whole series of really great projects, okay? So they'll walk you through like an entire game, which is pretty neat. It's pretty rad. And then, I think down here at the bottom, yeah, then they have a whole series of topics, okay? And let's see if I can find it here real fast. Like they did a whole great topic on just the new user interface stuff, because the new UI system came out, last year or the year before. And I mean, just look, these are all videos, by the way. And many of the videos, they actually provide you, I'm in the wrong section for this example, but many of the videos they provide you, here we go, C# scripting, they actually provide you with the code themselves, okay? So it's a great resource. Definitely go check it out. Like here's the destroy stuff. We were looking at this last week. Great little video, and they give you all the code down here at the bottom. Haha, right? Great place to get started, okay? Really good. Another good resource, and this is not necessarily game focused, but if you're really getting into coding, it's Code Academy. CodeAcademy.com does an excellent job. Code Academy. Code Academy does an excellent job of helping you learn how to code, do some basic low-level programming stuff. They actually have a really neat system. They allow you to, they have these small little games, kind of interactive exercises, if you will, that allow you to make these small little scripts. And you do all your programming in the browser, which is pretty neat. So you get to see immediately just right there in the web browser if it's working or not and how well of a job you've done. I think this is a great place to begin or continue your exposure to computer programming. It's pretty neat. Definitely suggest it. I've gone through the free version. This is a couple years ago now, and it was a really great experience. So I can't recommend it enough for you guys as well. So two really great places for you to go continue your education and learn some stuff that we're not even going to be addressing in this class. As I mentioned last week, the conversation about computer programming is very deep. My goal is to not make you into programmers, but everyone on a game development team needs to know a little bit about code, right? You need to be exposed to it a little bit. You need to understand, even at its most basic kind of simple moving parts and pieces, what's actually going on, okay? I think if I remember correctly, the example that I used last week is when you're learning a foreign language. Oftentimes we can understand the language before we can speak it. That's kind of what we're trying to do in here. I want you to be able to open up a script and to be able to understand the structure of it. Understand, generally speaking, what the script is trying to get us to do. You may not know how to write the code, or you may not know specifically, the structure and how to, the line, the commands and all that jazz. But at the very least, you should understand what it does, right? And that's really the idea behind this section of this course, okay? So last week, we were working with a very simple example. We spent some time prototyping and diagramming the function, the overall, kind of high premise ideas behind the little miniature game that we're creating. And one of the things that we started off with was the idea that we wanted to have a simple pickup game, right? Where you walk around, you grab a whole bunch of boxes, you get a point for each one of the boxes that you pick up. And then, based on the environmental challenges, you could accidentally die, and then, of course, if you lose all your lives, the game will restart. Okay? Let's just explore where we left off. And there it is. So the coin immediately got instantiated. We hit the coin, and it gets disappeared, or it gets destroyed. That's where we left off last week, which is a pretty good place to stop. I wanted to start today with a small little refresher and a reminder of how all of these different items are brought together to create the interactivity. One of the cool things about the design of our games is highlighting the small machines that generates the functionality. And part of our role as a game designer is to figure out what exactly we're trying to get the game to do, right? We may not be able to understand how to write the code to make that functionality, but at the very least, we have to know what we want the machine to do, right? We have to understand that it's going to go from A to B. In between there is lost to us, because that may not be our expertise, but we've got to be able to figure out and communicate to someone what it is that we're trying to get our game to do. Okay, so let me just walk through what we've created so far. Okay, and by playing the game, we can start to see the basic functionality of this come to life. I think it's a really great practice as we start to work with code to have our environment, our editor, split in half. That way we can see specifically what's going on inside of the game in the editor tab. And then, of course, naturally, what we see down here in the game tab is a direct representation of what we've constructed. So this is a good kind of edit environment for us. It allows us to prototype, debug, and test pretty quickly. So the moment I start the game, what happens inside of my editor? Let me do it again real fast. Command-P to stop the game. Look very closely in the editor itself. Command-P to start the game. What's the first thing that happens? Yeah, the coin pops up. What is this creation called? This act of creating things? Instantiation, right? Instantiation is going to be a term that you're going to hear a lot. It's the process of physically adding a prefab into our hierarchy, into our game hierarchy. Okay? If we look over here, oops, let me stop the game for a second. There we go. So if you check out what's in my game at the moment, we just have a directional light, the ground, my first-person controller prefab, a game object called script warehouse. This is just kind of an empty game object that allows us to attach scripts, and then the coin spawns. This is the location the coin is going to spawn. Okay. When I start the game, boop. Okay. What happens? It's going to be impossible for me. And let me stop the game again. But what happens here underneath coin spawn? You got it. You got it. It's instantiated into our game, and it's made a child of the coin spawn game type, right? And then when I touch it, boop, it gets destroyed. It's physically removed from our hierarchy, right? Now this is good practice for us. We want to be able to create and destroy at will, right? Because if we're not, man, our hierarchy is going to be bloated with a lot of things that the gamer might not yet be interfacing with, right? We don't want to have the boss that's on, a mile away from the gamer to be placed in the scene at launch, right? We want the game to instantiate that object when we get close to it, so its resources are not being tied up by something that we're just not even there seeing yet, right? So being able to add and subtract game objects into our game is a really important idea. We're going to add on to this a little bit today, okay? And we're also going to start to lay the foundation for some other fun stuff. Specifically, we're going to talk about how maybe we can add some new interactivity by adding additional components to an existing game object when an event happens. Maybe when I touch my coin, I want it to, fly out in front of me or something like that, right? That'd be kind of cool. We're going to look at how we can employ maybe some physics and how we can add and subtract components when an event occurs inside the game itself, which would be kind of cool. In addition, we're also going to talk about depth zones a little bit. and we're going to introduce a really big concept that's going to be a foundation level idea going forward called Booleans. And Boolean operators now become the foundation for kind of a simple logic system inside of our game environment. And I think you're going to see pretty quickly how fun and how important they are to the larger context of what it is that we're creating. All right, so first things first, let's go back to the coin and spend some time looking at the coin, because there's some things in here that I want to do to make this coin a little bit more interactive. Okay, so let's open up the coin destroyer script, take a look at it. Last week we also talked about creating some conditions in which certain if statements are going to happen. That tagging system that we explored last week is really important, right? I think you're going to find that one of the better ways of filtering your entire hierarchy in whether or not conditions are being met are with tags. It's really helpful, and we're going to do that a couple times today. We're going to continue looking at tags. We're actually going to create our own custom tag this week, and we're going to use the condition of that tag to drive the respawn of our character. All right, Visual Studio's loading up here. It's Friday, so it's just taking its merry old time. Yeah?
They say you have a coin. So in your game, there's a coin, and there's a whole bunch of like enemies roaming around.
Mm-hmm.
And you don't want, there's this like an invisible perimeter around the coin that you don't want your enemies to get into.
Yep.
It's not necessarily the coin that they're running into. It's like this perimeter, invisible perimeter.
Yep.
And you create a collider and have that tag to your player so that once your player hits the collider, it goes away and you get the coin.
Absolutely, and that's the idea, because we only want the player to activate the coin, right? We don't want to have some enemy AI that's cruising around deactivating and destroying the coin, right? We only want the player, and that's where that tag system comes in. Okay, I don't want to install the updates. I probably should install the updates, but I'm not going to install the updates. Because last time I installed the updates, it took an hour, and then at the conclusion of that hour-long wait, it said error. Yeah, and I think that's all it said, or unable to install. And I went, what? How do you get that error at the end of an hour-long installation period?
It never works for me when it is through the own program.
Uh-huh.
It only works for me through the Unity install.
Yeah, and that's the way to fix it. And I don't know if this is probably just a Mac thing. This is the first time Visual Studio has been available on the Mac, and clearly they're encountering some hiccups along the way. All right, so here's our coin destroyer script. Let's just walk through it real fast, because you can see that tag system in effect down here. Last week, we made this tag an active object inside of our structure by this if statement. And these are excellent ways to ask just a simple little question. If whatever hits my collider is tagged with player, then destroy this, destroy the game object, right? So this is the destroy command. When it's in parentheses, we have to tell it what to destroy. Right now, what are we asking it to destroy?
Self.
Yeah, it's itself. You got it, right? When it's a lowercase g, you're saying destroy whatever this script is currently saved to, right? In our case, the coin, or the prefab of the coin itself. Now maybe we can extend this a little bit, and this is kind of fun. I like doing this. This is a great way to add a little bit more interactivity inside the game itself. When we hit something, we can have it do a number of different things, right? Of course, naturally, we're going to destroy it, but maybe we destroy it after a time period. I'm going to put a comma there and put 3, okay? Because now it's going to destroy the coin after 3 seconds. Let's just save it. Whenever I make a change, I always save and go back to Unity and test it to make sure that it's actually working. I'm not getting any compiling errors, so I'm going to assume that life is good. We'll start the game. Dun, da, da, da. So, boom, 2, 3 should go away. There it goes. So it works. That simple little addition to the destroy command is pausing that action from happening for 3 seconds. Now, let's add some other fun stuff in here, right? Because if you notice, where my coin spawns is kind of up in the air. It'd be neat to, when I touch it, maybe have the coin drop on the ground and start to behave and become a participant of the physics engine inside of Unity itself, which would be kind of cool. So we're going to do a couple things here. Of course, we're still going to use this condition to determine the next action, but let's add in another action here. And this is a great way to start adding some fun functionality. So I'm going to do game object, okay? So I'm saying, hey, self, okay? And then we'll do dot add component. And this is where it gets kind of weird. We have to do the carets, okay? And then open and close parentheses, and then a semicolon, okay?
What are the carrots?
Yeah, so we're saying, hey, self, add a component, and then what goes in between the carets is the component that we're going to add to the game object, okay? So in our case, what we're going to do is that we're going to do a rigid body. Oops. Rigid body.
That hit after collision, and if hit, is that a code term for making contact? Or is
So
that arbitrary?
that's a good question. So the hit.gameObject.tag. So up here in the function, the parameter of the function itself, we're collecting collision information, okay? And we're storing that collision information inside of a variable whose name is hit. And then we're accessing all of that collision information down here, and we're asking a question against it. We're saying, hey, if whatever collided with me is tagged with player, then do that.
So yes and no. It's more of a name you gave to a variable.
It's a name that I gave to a variable. Yeah, I'm both creating the variable and naming it here, but I'm also data typing it. I'm saying the information that's stored in that word is collision information. Yep. All right. Let's see if this works. Let's save the script and return to Unity. We'll wait for it to finish compiling. It takes just but a second. Aha, we didn't get any compiler errors, so let's see if it worked. Bloop. Ah, there it goes. And then eventually it will get destroyed. Yeah. Cool, huh? Let's try it again because that was too much fun. It will. It will. So right now I don't think we're using a mesh collider. There it goes. We can kick it around a little bit before it destroys. Let's look at the actual prefab itself. Yeah, because we're using a capsule collider for this thing. Maybe, which is generating some really odd, interactivity. Yeah, not exactly what I'm after, right? So let's put the coin in here just for a second. So I'm looking at the prefab itself now, and yeah, it's a gigantic sphere. So we can make some adjustments to this if we wanted to. The capsule collider here really isn't giving us what we want. I mean, we can certainly play around with the radius and the height values. I don't think it's going to get what we're after. So maybe we, instead of using a capsule collider, let's remove that component. Let's add in, under the physics components, let's add in a box collider. Yeah, that may get us what we want. And I'm going to put it back. Oops, excuse me. Oh, you can do a mesh collider. Yeah, give that a try. Yeah, mesh colliders are really expensive because there's a lot of geometry and a lot of surfaces that it's looking at. I forgot. I was working off of a prefab, so I got to change the actual prefab itself. But now that I know what works, just a simple box collider. Let's try it now. Still gets instantiated correctly. Yeah, a little bit more believable now, which is kind of what I'm after, right? So this whole idea of adding a component to something after it's been instantiated is something that we're going to use often. So that's a good little code snippet, because the components that we can add and subtract and adjust are basically all of this stuff. So if they end up over in here, these are all the components that we have access to in code. Yeah, go ahead. Okay.
One of the coins reacts normally, the other one makes 2 coins when I hit it.
Awesome.
I don't know why.
I don't know why either.
2 coins.
Yeah, I don't know why either. Now, it probably if you have multiple instances of this coin being instantiated, we're probably not doing the correct structure at the moment to ensure that the rigid body is getting applied to the correct, or to each individual instance of the coin. this is kind of going back to what we were talking about before. There is some structure that's kind of advanced, and I'm saving for a couple weeks before we really jump into that. Okay, so let's just kind of revisit where we are at the moment. So it's sitting there, and then the moment I touch it, poof, the rigid body's added, and then 3 seconds after I touch it, it goes away, which is pretty cool. All right, rock and roll. I like this. This is a step in the right direction. Let's stop the game. Yeah, go ahead.
Off topic, does that texture look like it's actually, well, bump or bump wrap or something?
On the ground? Yeah, I believe on the ground.
Sticking out.
Yeah, it's. I think it's just a normal map.
Okay.
Yep, I don't have a height map on here, just a normal map. Yeah,
So
in
like
the.
in a lot of games, like a lot of shooters, you know, you kill enemies or whatever, they fall on the ground, and most shooters, the enemies disappear after a while. It's the
Yep,
same exact.
same. It's in principle the same idea, right? There's a lot of technology in between A and Z that gets you there, but where they're adding some sort of, some sort of component that enables that game object to participate in the physics engine, and then there's a period in time in which that dissolves away, fades out.
Could you pop up the code window?
Sure,
So
absolutely.
you want to see it?
Excuse me. Yeah, go ahead.
Just kind of curious, would it be possible to add like a first person, no, the character controller
Mm-hmm.
in there and just have them replace the coins and push them around and have it seem to like fly off or.
Oh, yeah. So, oops. I'm in the wrong app. So instead of adding the component, the rigid body component, when we touch it, it could just be there from its initial get-go, right? Because right now, if we look at the original prefab of my coin, all we have in here as far as components go, of course we have our transform component, the mesh filter, the mesh renderer, which loads in all of our materials. This is the coin destroyer script, which physically makes it go away after 3 seconds. The box collider, which is going to detect the collision. However, I could go in if I wanted to, under the physics engine, and add the rigid body itself, just as part of the core components of the game object, right? Now, I need to make one small addition here. I'm going to comment out that line of code, save it again. That way it's not evaluated by the compiler. And now, when I instantiate it, see how it just drops? I can push it around. Oops. Well, now it's too small and I can't push it around. But if it was a box, I could push it around and do whatever I wanted it to. Yep. Yeah, the rigid body game component inside of Unity allows us to kind of participate in a physically based world. All right. Other questions? Excuse me. All right, so now what I want to do is start getting into some new stuff, okay? And this is where it gets kind of fun, because what I really want to have happen here is to create a death zone, okay? So there's a couple things in here that we need to prototype and consider before we just start jumping in and writing some code, right? Because I really honestly believe the best place to begin, especially when you're first learning, is to figure out what the function of your machine is going to be and then build it. If you're building the machine as you kind of understand the functionality, it's probably never going to work, okay? So let's kind of figure out casually here what we want our machine to do, and then we can build it to do just that one exact thing. So for our death zone system, I want if my player was to walk over the boundaries of my map, right? Or if it was to, a character to fall into a pit. I want it to hit something, and then to die, and then to respawn, right? So as soon as the character goes over the edge of the map, I want some sort of state to change that allows the computer to understand that you are now dead, okay? Maybe a couple things can happen when that condition's met. Maybe you lose a life. Maybe there's an on-screen graphic that appears that says you died. Something like that. I don't know. There's a whole series of things can happen when that condition's been met. And then eventually I need to place the player back at some sort of defined starting location, right? So we need to reinstantiate or just physically move the player back to where we need he or she to be, okay? So that's what I want it to do. I want to have some sort of collider that when I touch the collider, a new state of the game has been created. We'll just call it dead, okay? And if you're dead, then a whole series of things are going to happen after the fact. One of which being we need to replace the player at the starting point of my level, okay? So there's a couple things in here that we need to build. We need to have some sort of collider that determines when you're dead, right? Some sort of object in the scene that you physically pass through that determines if you're dead. We're also going to need to have some sort of starting point for the player, because if we need to return the player to a defined location, I have to define what that location is, right? So there's some game objects in here that I need to create. So let's do those first, okay? Now for the death zone, this is a really easy system, okay? We're going to make a couple colliders, okay? Much like we did with our coin, I'm going to create an empty game object initially, okay? And let's just call this thing death zone. Okay, and on the death zone, we're going to add a simple collider under the physics area. And we're just going to use a box collider. Now the box collider has a whole series of properties that we'll definitely want to take a look at. I'm going to go to the transform component of the actual death zone, of the death zone game object, okay? And I'm going to reset its transforms, just so it's right there at the origin of my three-dimensional scene. Now, I like putting it there because it allows me to, keep everything nice and centered around the origin of my scene, but it allows me to very directly understand the size of my death zone, where it's placed inside the three-dimensional scene. Just makes it a little bit easier, okay? All right. On the collider itself, we have some properties in here that we can change, which is pretty great. One of which is size. I think I want mine to be pretty big. Initially, let's put it at like, I don't know, let's put it at like 60. That'll do. 60 on the X and the Z. And then I'm just going to move it down so that it's below the plane, somewhere right around there. I don't want my character to fall too far before before he or she respawns. So that's a good start to go. All right, cool. So there it is. There's the death zone itself, just a big collider. Awesome. Now the other thing that we need to create in here is some sort of character spawn, and that's just going to be an empty game object, because much like we did with the coin spawn location, we need to define in code perhaps the location where we want our player to be returned to when we die. So here's our game object. Let's just rename this game object player spawn. There we go. And all we really care about is this transform information, because this location here, much like we did with our coin, is what we're after. All right, so where is it? Here, I'm going to give myself some landmarks here, just so it's a little bit easier to understand how all this is working together. I'm going to make just a simple little cylinder. Make it big. Sorry, say again?
You just brought a new cylinder in there?
Yeah, I just created a 3D game object with a cylinder. That way I have some reference in here, that's all. Let's duplicate that guy. So the area of my mesh, or the area of my level with two cylinders, is generally where I want my player spawn to be. And yep, it's kind of over there, which is kind of nice. Oops, I clicked off it. Let me grab it again. All right, so that's where my player is going to spawn if this whole thing works the way it's going to work, right? So we've created the objects that we need in order for this little machine to work. Now we've got to start writing some code. And the first thing that we need to do here is that we need to figure out when to know if we're dead or not. That's an interesting idea, right? Because that whole death idea, once we've touched that death zone, is really going to be the driver of a whole series of actions. Okay. So let's do this. We're actually going to copy some code from our coin system, copy some big ideas, because we've already kind of done this in practice a little bit with our coins. So I'm going to create a new script before I go any further. Let's just call this character controller, because this is going to control the actions of our characters now. Let's double click on it. It'll open it up in good old Visual Studio. All right. And if you remember over here in the coin destroyer script, we've already been doing some basic collision detection over here, right? Now we want to maybe copy this idea because when we collide with our depth zone, we want something to happen, right? Let's put it together real fast. I'm just going to copy some of this stuff. Copy over here. And put it after our update function. Okay, so it says public void on collision. We'll remove, yeah, we'll keep that in here for, yeah, that's good. Collision hit. So if.gameObject.tag equals player, you know, this is the stuff that we're going to change. Okay. But this is the structure that we're going to use. Now for the tag, it may be a good idea to only have the player respond when it interacts with a tagged item, right? So only respond when you hit death zone, right? This tagging system is an excellent, excellent, excellent way to filter game objects by their role, almost, okay? So I'm going to have a tag, just be death zone. Oops, excuse me. Death zone, okay? And close quotes. All right, so I'm declaring a new tag here. So let's go back over into Unity and physically create it, because I need to have this game object, the big collider that's underneath my map, adopt this tag. This is where we go to tag game objects inside of our scene. We did player last week, but we're going to add a new one, because if you look at the list, clearly there's death zone is not on that list. So we need to add our own custom tag, and that's one of the cool things about working inside of Unity is that you can add as many tags as you want, which is pretty neat. Okay, you start the process, of course, by hitting a little plus sign, give it a good name, hit save. Okay. Now all we've done in this step is create the tag. We haven't assigned that tag to an existing game object. So we now need to go back to our death zone and physically tag it with that tag, that custom user tag that we just created. All right. So the logic behind our script at the moment basically states if our character goes and touches the tag or touches something that's tagged death zone, something's going to happen. Let's test it. Let's test it in the simplest form possible, and that's just some sort of console log. Okay. Now our character controller script, that's where all of this functionality is going to be placed. It's currently not assigned to a game object inside of my game. I'm going to put it on my Rigidbody first-person controller. Okay. There it is. Here's the character controller script. Let's return to Visual Studio and give us some sort of ability to test against whether or not this if statement is rung true. So if whatever hits the game object, or if I hit something that's been tagged with death, okay, death zone, let's just debug. Debug.log. What are we going to put in there? Oh, I don't know. You're dead. Okay. So if we see you're dead pop into the death zone, we know that this collision system works at its most rudimentary level, right? I'm a big fan of testing collision and testing whether or not these if statements have come true, because we're about to make it more complex. If it doesn't work now, it's going to be really, really difficult to debug this entire system going forward. It's easy to debug something that's simple like this, much difficult when there's 80 lines of code in there, right? So you want to kind of give yourself these little marker points as you create your code. It's really helpful. Let's go back over into Unity. Yep, don't have any, unexpected symbol, end of file. Let's see, I messed up somewhere. Yep, I deleted on accident. Apparently curly braces. Save it. Let's go back over into Unity. Aha! No compiler errors. Life is good. Let's see if it works. Okay? So I'm simply, life's tough. Goodbye, cruel world. Aha! Mission accomplished. Because if you look down at the log, it says you're dead. Woo! Yay! Our collider works. And the if statement rings true, right? So we know we're testing against that tag correctly. It is working. But clearly we're not getting the function that we want. So now it's time to go in and expand our code a little bit to physically create the action that we're trying to get. Okay, so what do we want to have happen when we hit death zone? It's a good question, right? earlier when we were prototyping this big idea of a death zone, we created this idea that maybe there's some sort of state that the game goes into that says you're dead. And then a whole bunch of things are going to happen if you're dead, right? This state is going to be our first Boolean operator, okay? And Booleans are kind of like true-false statements. I kind of think of it like a light switch, right? When the light switch is up, the lights are on. When the switch is down, the lights are off. True, false, right? When we enter into the death zone, this idea, this Boolean is true, right? And then when we respawn, of course we're not dead anymore, we're alive, so then the switch gets flipped the other way, okay? It's a great way to add some simple logic and a condition that we can program against inside of our game. It's an excellent, you're going to see Booleans all over the place. I'm a big fan of Booleans. It's just a switch that's been flipped inside the game, okay? Yeah, question?
I remember when Booleans were like true or false statements, right?
Yep, it's a true-false statement. You got it.
Gotcha.
Yep, it's a switch. If we activate the switch, it's true. But there has to be something in the game that flips the switch back the other direction. So we have to have it go both ways, because this is something that we can switch at any time. It's like a door that opens and closes, right? Initially, the door is going to be closed, but we can open it. But then something's got to close the door back again so that we're allowed to open it once more, right? All right, so let's go in and start. Let's go back into Visual Studio and start creating this Boolean statement, okay? So the first thing that we have to do, okay, is that we have to declare the Boolean. We have to physically write the variable, okay? And we do that right up here. So I want to make this a public variable, okay, and go bool, okay, for Boolean. It's appropriate since we're in the month of October. Bool. Anyways, I'm all excited about Halloween, so everything's like boo for me. Anyway, all right. So now we got to give it a name. This we data type the variable first in C#, and then we give it its name. Okay. So I'm just going to call this dead. Okay. So the name of my switch is going to be dead. So let's figure out how we're going to do this, right? Much like what we did down here, let's see if we can flip this switch. Okay, let's see if we can have access to this information. So when we hit come on now. When we hit the switch, or when we hit that death zone, we want to flip the switch, okay? And maybe we'll keep this debug.log down in here so that we can understand if the switch has actually been flipped, because we really don't get a whole lot of info on whether or not the condition's been met. So let's do this, okay? Let's do dead is equal, we're going to set it to true, okay? Now, if we're setting something to true, maybe the first thing that we need to do is actually set it to false, right? We always have to have something, we always have to initially create the state of a Boolean. So let's do that up here in the start function. The first thing the game does, okay, is set dead to false, okay? Which is cool, right? It's off when the game starts. And then when we go into the death zone, it's true, okay? I'm going to extract this debug.log. I'm going to cut and paste it from my onCollision function, okay? And I'm going to put it in my update function, okay? Because I want to have a little printout in my log that tells me the current state of this Boolean. That way, when we enter into the death zone and the flip is switched, we'll get some immediate feedback on the current state of things, okay? However, we're not going to put you're dead. This is a cool little trick. So we'll put the Boolean state is, okay? So anything that's inside the quotes, all of this jazz, this is a string, right? This is just text. That's all it is, okay? This is user enter text. However, I want to append some user enter text with the current condition of the Boolean, okay? So in the debug.log section, it's always going to stay the Boolean state is, and then the current condition of the Boolean, right? We're loading in the variable into the debug.log properties with this in here, plus dead. Okay? Let's save it. Go back over into Unity and see what's going on. I'm just going to clear my console. No compiler errors. Good job, Pat. Okay? Let's see if it works. Game starts. Ah, look at this. The Boolean state is false. Yay! All right, that's good, right? So it's actually listening to the commands I told it to, right? Because I told it once the game starts, set dead to false. Boom. Aha, it says false. Okay? Let's jump into the death zone and see if it flips to true. Okay? And then we really know if we're flipping this switch or not. I'm just going to walk into the dead zone. Boo! Boom. And the moment we cross through the dead zone, check it out. It got flipped to true. So we know we have an active switch. We know the logic that we've created inside of our script is flipping this little light switch up and down. This is what I'm after. Okay? I think it's a really great practice to test as we go because we've created a very powerful Boolean, but we're testing its functionality with simple debug.logs, right? With simple little console prints, which is nice. All right. So now that we've tested it, clearly we don't want to have this in here anymore. Okay, that was just a test. Okay, so I'm going to get rid of it. I don't want to have that always be popping into my console in every single frame. Let's actually do something. Okay. So let's add in a new layer here. Okay, because maybe when we're dead we lose a life. That's a cool idea, right? So in order to lose a life, what do we need to create? Yeah, well, before we even get to the life UI, that's going to come next week, okay? A variable. We have to have a container for some data, right? A container that defines some information, right? In this case, just a number. These containers, Kevin, what are they called? Variable. So you got it. So we need another variable. I want to make it public so I can access it both internally within this script and then externally and referenced by another script. So I want to create another variable. This one's going to be an integer. In C#, we data type integers with int, and let's name this variable lives. Okay. Much like we did with our Boolean, we've got to tell it how many lives to start the game with, right? How many lives are we going to have? 2? Sue was like hardcore. He's like, you only get 1 try. Let's give him 3. We'll split the difference. Okay, we'll give our player 3 chances to meet the win scenario. Okay.
Integers is a countdown system, or
It's just a number. That's all it is. The whole number, right? Does anyone remember if we wanted to have like 1.1 or 1.2? What kind of data type? What kind of value is that? Float value, right? So like 1.21, those are float values, okay? Whole numbers are integers, okay? And for something like this, we're definitely going to want to use some integers to start putting this out. Okay, so now we have, this is where it gets kind of fun, right? Okay. So, excuse me, now that we've defined a data type that we need to adjust, how are we going to adjust it? An if statement. Yeah, I like that. So maybe if dead, subtract a life, right? Where within this structure are we saying, do we have an existing if statement? But on collision, right? So maybe we extend this a little bit, okay? For the time being, let's just keep it real simple, and then we'll make it more complex. So when we hit the dead zone, we're going to change the Boolean to true, but let's just see if this works, okay? Let's also subtract a life, okay? So we'll do lives. And this is how we do it in C#. Minus equals, that's plus. Minus equals, okay? Now we have to tell it how many we want to subtract. Should we subtract how many lives? 1. You got it, right? So we'll minus 1. And of course, a semicolon. Okay? To test it, how are we going to test it, right? Perfect. I love it. So in the update, let's do debug once again, .log, parentheses, quotes, and then I always go and put my semicolon there at the end. Let's put number of lives, and then we'll do plus the variable. Okay. So now in the debug, in the little console, okay, at the bottom of our application frame, we're always, since we're putting it in the update, we're always going to get a little line of code that says the current number of lives that we have. When we hit into the def zone, bloop, we'll subtract a life. Let's test it. Let's see if it works. Okay. We state at the beginning of the game that we're going to have 3, and then when we touch the def zone, we're going to subtract a life from that total. Let's save the script, return to the Unity, see if it works. It's compiling. Yep. Okay, we're good to go. We're off to the races. Aha! We already can see that it's working a little bit, right? We can see just based off the console down here, number of lives equals 3. So that initial value that we set on the start function is working. Good job, Pat. Yep.
Where do you put the script?
I put it on my Rigidbody first-person controller. Yeah. Let's walk off the platform again. And then, bloop. Excellent. It worked. It did it. Okay? Number of lives went down to 2. So we know that that action is working correctly. Okay? So we've created a Boolean that defines whether or not we are dead. We created a simple system that creates a value that defines the number of lives. And now we're subtracting from that value when we interact with the death zone, right? In its bare bones, the system's working, right? We've created the functionality, but now we can just do it better, right? If we return to our code here for a second, there are definitely some opportunities in here for us to optimize. Let me get rid of that tooltip for a second so we can see what's going on, okay? Now, I love our start function. This is a great thing to do because often when you start a game, you want to set some data values, right? But how we're registering death, okay, that's working. But what is the outcome of that is probably an area that we can start changing a little bit, right? Because really what I want to do here is that I want to have something else activate when dead's true. Because what if we want like 8 things to happen when you're dead, right? In the grand context of a very large game, man, there's a whole bunch of stuff that's probably happening when you're dead, right? You know, when you die, your health is going to be reset, your mana is going to be reset. Maybe you're going to be transformed to a different spot in the scene. You could have a huge laundry list of things that need to change to return the player to a state that's when they respawn. So having all of this happen in one function down here at the bottom is probably not a really great idea. Okay, I'm going to start stripping out this lives minus 1 and put it in its own function. Okay, that way I can start adding commands. So the only thing that I need to do is just to listen if something's dead. Then a whole laundry list of things are going to happen. We're really going to utilize that Boolean. Booleans are like switches. Okay, the whole function behind this on-collision system is just to flip a switch. And then we want to have another system be listening for that condition. If dead is true, let's do a whole bunch of stuff, right? Let's start creating what that's going to look like, okay?
Is that written right where it's lives minus equal 1?
Minus equal, yeah, you got it. So I'm subtracting a life every time. Yeah.
One equals changing.
Bingo, yeah. Yep, when it's 2 equal signs, we're comparing. Yeah, when it's 1 equal sign, now we're setting or changing a value.
And does it work the same way if you wanted to add 1? It's just plus equals that number?
You got it. Plus equal is going to add a value. Let's test it real fast just so everyone can see it. That's a cool thing to see in action. So, oops, it's Friday. I can't type.
Can you do more more complex mathematical functions for that kind of adjustment to things?
Absolutely, yeah. I'm a simple guy, so I'm going to keep my math simple for Friday afternoons. But absolutely, you can, for sure. Yeah.
Quick question. How do you get rid of this goddamn 2 audio listeners keep on saying?
Yeah, so the two audio listeners are coming from your main camera. The main camera has an audio listener. The default main camera that comes with every Unity scene file is going to have an audio listener. Just delete that main camera. All right, so I changed my syntax ever so slightly. Now when I jump off the cliff, I have 4 lives instead of 3. I've added a value versus subtract it just by doing plus equals versus minus equals, which is what we had before. All right.
So you can apply it to like a, let's say like a green mushroom.
Bingo, right? Or in our case with the coins, this is it, right? When we touch a coin, boop, plus equals 1, right? Yeah, absolutely. Anything really, yeah. Score, deaths. Yep.
And then you would just apply the self-destruction scripts to the coin or the green mushroom and have it go away. You gain 1.
You gain 1. Yep, you got it.
Will it go into the negatives if you keep moving lives?
Yeah, yep, absolutely.
So you have to write statement if 0.
If 0, yeah, exactly. Then do that. We're going to get into that next week because we're going to add some. Yeah, or if we're at -1, probably 0 would make sense, but.
Can I see the tippy top of that script? Do you have a bool?
Absolutely. So at the very beginning,
Okay, there.
yep.
I can't count how many games just go, oh, you have 0 lives. This is your last chance.
Okay, so there's one thing that we need to prototype still before we really start kind of condensing this into some smaller things. That's the respawn system, right? Because I mentioned before that when we're dead, we want the player to go back to a very defined location, just like we did with the instantiation of our coins last week, right? If you remember back at the beginning of our conversation, I created a game object called player spawn. So wherever this game object is currently living inside of my scene, that's where I want my player to go when they're dead, okay? So I want to be able to access that a little bit and get this working. Right now, it's in between my 2 cylinder thingamajigs. So let's go back over in our code and see where we can do this, okay? Now, just for simplicity, let's put it down here inside of this if statement, okay? So if we hit the death zone, we're going to flip the switch. We're also going to subtract the life, and then we're also going to move the player, okay? Let's get that working a little bit. Much like we did last time, we need to move the location of our object to a defined location. And this is absolutely piggybacking off of the coin creator script, okay? Because you remember, in the coin creator script, we instantiated something, okay? But upon instantiation, we got to tell it what to create and where to create it. So we're kind of going to be piggybacking on this idea that we're going to go find a game object that's currently residing inside of our hierarchy, snag its position, and apply that position to our player. That's the big idea, okay? So let's, yeah, go ahead.
What's the difference if you move the player instead of instantiating?
This was for the coin, which is why we're instantiating it. But for ours, we're just going to move it.
Oh.
Yeah. We're borrowing the idea of the coin, not the actual, well, this we're actually going to steal. But we're actually going to move it. So let's go back and start moving it, right? So to move the player or the owner of this script, of course, we need to access its transform, okay? I totally just misspelled that. Transform.position. So we're saying with a small case t, move me, right? Since the game controller has this script as a component, the game controller is going to get moved. Okay, so move my position. Well, where are we going to move it? Whoops, excuse me. We want to set my position. We got to go find something. GameObject.find. GameObject.find. Okay, and specifically, what I want the computer to find is this thing. Player spawn, that game object, okay? We're going to find this game object, and then we're going to snag its transform component, okay? Because we want its location. So GameObject.find, what was it? I think it's called player spawn. And we have to be very, very careful here. I'm actually going to copy and paste the name.
So on the player spawn or anything in general, does it have to be match it, like lowercase, uppercase?
We're looking for a very specific game object, right? So if I misspell it in any way, if it's off by one character, it's not going to find it, right? Because we're saying find a game object that matches this name exactly.
Okay, so it matters.
It matters big time. And some of you may have just saw, I just copy and pasted the name of the game object into my code to make sure that I don't have any butterfingers, because I'm going to misspell things, especially on a Friday afternoon where I've had a lot of coffee. So.
I noticed you've been doing the convention too, where you do lowercase first and capitals.
Yeah.
Is that
It's a good practice. It's good practice. It's called Camelcase. Okay. It's a way for us to. What we don't want to have is spaces. Okay. So a lot of folks have. This is a no-go, right? We can't have a space between the words and our names, right? Because certain programming languages will interpret that space as the beginning of a new file, the beginning of a new command, the beginning of something else, right? So spaces are no-go. How you write it is up to you. It's hard, with the darn autocorrect in there. I just put an undercase. Some people do that. I mean, however you want, just no spaces. Camelcase is a very kind of popular convention out there, where the first letter of the first word is located, and then the first letter of all following words is uppercase. All right. Okay. So we're not just finding a game object. We're actually going to take its transform, right? Transform dot position. Okay. So when I hit the def zone, flip the switch to true, subtract a life, and then move my position to the position of this game object that I just asked the computer to find. Okay? Aha! We'll see if it works. Did I put a semicolon in there? I sure did not. Let's put a semicolon in there. Go back over to Unity and pray that we don't have any compile errors. Hey, look at that. Okay, so my player spawn is way out over here in between these two cylinders, which is why I put them there. Let's see if it works. I'm just going to walk backwards. There it is. Now I'm in between. I warped over between those two cylinders. Let's try it again. Woo! Boom, I even lost a life too. It's working. Okay? Yeah, go ahead. You're not having the teleporting. Okay. So here's my script. All right, Mike, what is the problem that you run into?
I just don't think I have the script in the right thing. That's the problem. I'm pretty sure.
What do you have it attached to?
Let's see. So I have the script attached to two things: the death zone and the FPS controller.
Yeah, we only want it attached to the FPS controller.
Oh, okay.
Yeah, we don't want to. There's basically nothing on the def zone.
Okay. Let's try this. Still not.
Okay. So where's your def zone game object?
Death zone game object is this right here.
Okay. All right. Now show me your script here, your character controller script. Did you tag your def zone?
Yeah, I tagged my death zone.
Let's be sure.
Nope.
Yeah, okay, good. I can see it there. Now you put your, now you're using the FPS controller, right?
Yeah.
It may be a good idea to use the Rigidbody FPS controller in here. That way we can detect these. I've noticed with there's each of the prefab game controllers has a corresponding script. The Rigidbody FPS controller does a much better job of determining this interaction. And then put Rigidbody FPS controller in there. That works better.
Can you add a timer to that, like comma 30 to the respawn?
So the respawn, yeah, a little bit. Yeah, for us it's wait for, and we put wait for seconds, and then we can say wait for 3 seconds and then respawn. Yeah. Yep. All right, let me see where we are here. Yeah, so this is cool. And check it out. This is actually kind of a really neat reinforcer of the idea here, right? Number of lives, I must have walked off a second ago, but number of lives was set to 3. I walked into my def zone, now it's at 2. Okay, let me jump off the cliff again, see where we're at. Woo, set to 1, set to 0, set to -1, -2. I could do this all day, right? Yeah.
Pat, so right now you're using find player spawn. Could you have a script where instead of finding that specific game object,
Mhm.
you have it as like a variable that you put into the script?
Absolutely, of course. And that's what we did.
Looks like.
So it would look almost identical to this, because that's what we're doing here, right? We're declaring a public game object called the coin prefab, and we're declaring a private game object called respawn location. Okay? If you declared this as public, it would show up in your inspector, and then you just drag it in there if you want it. Let's just do that real fast. Yeah, let's just do that real fast because it's really kind of easy. Okay, the only thing that we have to do, let's see. Yep, okay, cool. Let's see if we can get that to work real fast. Instead of doing all of this stuff, let's put, what's the name of the variable going to be? Let's do player respawn var. There we go. Why not?
Matt, with doing the debug log where it says the Boolean state and it sort of calls to asking what the Boolean state is, how do you make it so that it says true or false? Because I just keep saying the Boolean state is dead.
That's how I did it. Instead of lives, I put dead in there, and it should just read whatever condition. It should just print.
But not inside the.
Yeah. Oh, yeah. Not inside the quotes. Yeah, it's after the quotes.
Got it.
Yep. All right. So I made a variable here. I need to declare that variable out over here. This is public. This is a game object. Its name is player respawn var. Okay. So now this should be exposed inside of my expector. Then transport. Let's see if that works. Okay, so, yep, good. Yep, there it is. Check it out. Player respawn var. That's the public transform. Now, let's see if it works. I can drag that thing in there. Let's see if it works. I'm not sure if this is going to work. It works. Yep. So 6 to 1, half dozen to another. You get kind of the exact same thing.
There are times
Yep.
where I need that exact where you add it. It's
Yeah.
driving me crazy trying to do that.
Yeah, some people, you know, and I think this really kind of, it's just a preference. Some people like doing, hey, go find something. Some people like exposing it in the inspector so you can drag and drop it. I've met with some developers that hate dragging and dropping things in the inspector, right? They just want to be able to look at the code and see where all these game objects are going and how all this information is flowing, exclusively looking at the scripts. They don't want to have to actually go into Unity and look at the inspector. So it just kind of, it's a preference, really. It gets you to the exact same thing either way. I'm going to go back in time just a couple steps just to return the script to its previous state. I don't want to confuse anyone. I made a big change, so I've saved it. I want to return to Unity and just ensure that those saves have not broken anything else.
Will it break the script if we add like some kind of
No, great.
small collider to the player spawn, just so we know where it's at?
You certainly could, yeah, for sure. Another way of doing that.
Because I just like to know exactly where it is, because unfortunately that's not very helpful.
Yeah, and what is it? Yeah, you have these icons. So here's player spawn. Let's make it a purple diamond. And now, even when it's not selected, that purple diamond there will show you exactly where player spawn is going to be.
That's cool.
Yeah, and I think you can also go in and it's this thing right here. So I have the game object selected, and if the icon's set to none, it just looks like the box. But you can go in and change it. You can even load your own, I think, if it's a texture. Like, I'll use my play button as an example. or that didn't work for, maybe it has to be in the right format. But point being, that's better, because now it actually says player spawn over there.
Was the alive dead Boolean?
Uh-huh.
Do these things execute in the order that you put them in? What I'm saying is because once the player respawns, their Boolean should be reset to.
Yeah, and we're not doing that yet, and that's one thing that we haven't added. Yeah, because that's an important idea. We just haven't gotten there yet.
Okay.
Yep. Yeah. All right. Let's get back on point here, because where we are, because we've basically created the system, right? This is actually what we want, right? We're killing the player. We're subtracting a point from, or subtracting a life from its bucket, right? And then we're moving up the player back to the respawn point at the beginning of the level. We like that. Okay, but this is a very inefficient way to write it. Okay, because everything is happening in this one function, right? Ideally, we want to start breaking these out a little bit. So the whole purpose of this onCollisionEnter is just to flip the switch to true. As Taylor pointed out, we actually don't flip the switch back to false, so we're going to need some sort of container to facilitate that. And maybe, kind of going back to the idea that I mentioned earlier, maybe there's more things that we want to have happen when we're dead, right? Cool idea, right? So let's start breaking this apart a little bit and making a little bit more of a, I don't want to say complex machine, but a little bit more of an editable machine, a machine that we now can extend very, very easily. If you think about it, there's two things that are happening on these two lines of code. We're subtracting a point, or subtracting a life, and then we're also respawning our character. Maybe we should start splitting those apart from one another, providing, creating their own custom function, because maybe when we subtract a life, we do a couple other things too, right? Maybe when we're dead, or when we subtract a life, we have to reset its health back to 100, or reset the mana back to X, Y, and Z, or maybe we have to clear out its inventory. There could be other things inside of this command, or inside of this function, that we'll need to add to get the functionality of our game, right? Same with a respawn, right? Maybe it's game over, and we need to respawn the character back at the beginning of the level. If that's the case, perhaps we also need to close all the doors to the level, put the enemies back in their original locations, and basically get it back to its default starting position. So by splitting these things out into their own functions, we give ourselves the future ability to expand those functions to create something that's a little bit more interactive, right? So let's do this. Let's start making our own functions. So we'll start here with lives, okay? All right, so I'm going to create my own custom function here, and let's call this void. So we can just, and I'm just going to call this one subtract, I don't know, lives. So it's my own custom function called subtract lives, and at the moment, all this one's going to do is just subtract a life. Okay, I'm just cutting and pasting. I don't need it in here anymore. Okay. In addition, we're also going to have another custom function called what did I put? Just respawn. Open and close parentheses. Open and close curly braces. Curly brackets, excuse me. And then in here, this is where we want to physically move our player back to the respawn location. Okay, so the only thing that's happening here, the only thing that's happening here is the switch is being flipped. Okay, what's actually, when is all of this stuff evaluated? Excellent question, right? At the moment, it's not. So maybe we start writing a little bit more inside the update function. Maybe we're always asking the update function, are you dead? 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 Are you dead now? Are you dead? Are you dead? Right? If the update function is always asking that simple question, then when we do happen to stumble into the death zone, something happens, right? So we'll say if dead. Okay? And what we're saying here is if dead is true. Okay? If we just say if dead, that's basically saying if dead's true. If we want to say if dead is false, that's that, with an exclamation point in front of it. Okay? So if dead, let's get rid of the exclamation point. If dead, well, what are we going to do if we're dead? Respawn and subtract a life. You got it, right? So let's just physically write the names of those custom functions that we did down here. We'll just subtract lives. If we're dead, we're going to subtract a life. Okay? And we're also going to respawn. Bloop. Let's save the game, or save the script, return to Unity, see if this works. No compiler errors, life is good. Funk. There we go. I jump off the cliff. Whoa, I get spawned. Whoops. Look what's happening. Negative. Why is this going on like this? Why is this infinitely going to a negative value?
Because you're still dead.
We're still dead. We're still dead. We never flipped the switch back, right? We told the computer once we jump into the death zone, you're dead. And if you're dead, subtract a life, okay, every frame, okay? And I'm actually respawning myself every single frame right now, okay? I haven't changed anything, and so it looks like I'm just staying in. But we need to flip the switch back, okay? Whenever we have a Boolean statement inside, it's a true-false statement, and we need to ensure that we've written the functionality of the flip being thrown to true, and then something has to flip the switch back. It's not automatically going to go, right? So we have some options now as to when we want this flip to switch. I'm going to stop my game, Command-P. And I think I'm going to put this back. So here's, when we hit the death zone, we flip the switch to true, okay? I think I'm going to put it back. Let's see, which one of these do we call first? Subtract lives do we call first? Because the moment I want it to be flipped back, the moment, yeah, so I'll put it right here. So dead is equal, we set it to false. Save it, let's go back, see if it works. Chunk, number of lives equals 3. I jump off the cliff, lives are 2, boom, it's working, okay? If I jump off again, bloop, I respawn, lives are 1. Get my coin, its rigid body turns on, it'll disappear here in a second, as it just did.
I overshot my death zone.
You overshot your death zone? Yeah. Yeah. So it works. It works. Okay? The cool thing about what we've created here is that we're starting to create conditions, almost kind of states of our game. We're going to continue to expand upon these Booleans as we go over the next couple of weeks. But this simple logic, this simple true-false statement, is now going to become a major driver in the creation of our code going forward. Yeah?
So I guess with this particular type of coding, I don't know how it is for other coding, but it kind of seems like you want your code to basically be up top, and then you want it to basically be expanded upon at the bottom, something like that.
Yeah, you got it. And I think that's I think you're pretty close. Because what we've done, we've created a whole bunch of simple little machines here, right? We have a machine that's just going to subtract lives. We have a machine that's just responsible for respawning. Because there could be other conditions inside the game that's going to subtract a life, right?
Yeah, you have your general machines on top, and then beneath that, you go into detail about your machines.
Yeah, maybe. Yep. Because there could be other conditions that respawn you, right? You could go through a magical mirror, and that will respawn you at a certain location. Well, we've already defined that it's all we have to do now is if we go through that magical mirror, the one line of code that we're going to call is just respawn, right? You eat the green mushroom, respawn, right?
You respawn in a different location to get that knocked back at your original thing.
Yeah, you got it. You got it. And there could be other things that subtract a life, right? You get eaten by the gigantic mushroom. You lose a life. But maybe you don't respawn. Yeah, you get punched by a mushroom, you lose a life, but you don't respawn. Something like that, I don't know. So there could be other conditions that will cause these machines to be activated individually. Questions on this? Pretty cool, right? It's pretty cool. It's pretty neat. It's pretty neat. I like it a lot. All right. I'll tell you what, we've been going for about an hour and a half. Let's just take a small little break. We'll come back in and we'll start looking at error levels. All right. So, does anyone want to share and get some feedback on your current state of your level? Did you guys bring your level with you, as asked? Does anyone want to share what they've built so far? Get some good feedback on it? Yeah, okay. What computer number are you in to go? Nine.
Are we finished with the scripting for the day?
We are, yeah.
Okay.
All right, take us on a tour. What do you got?
How should I start off?
Yeah,
Just story?
just walk us through what we need to know, the bare bones of the experience.
Alright, so we've fallen into this level. This white stuff is dust that will hopefully animate one day.
Kind of like a shaft of light coming down. Okay, cool.
That's my representation of officer Rigidbody. So over here is a locked door, and it needs a key. You can see that by the little keyhole in the nose. Figure out that this is pushable based on the way it looks in the door. You push it out of the way to reveal it in the door. So you come in here, and this door is actually open, but you can't see that yet. And right now you can't do anything other than just go through this open doorway to this next room. So you push these frog statues into the water, get across.
Now, before we go any further, let's stop right here. Okay. Why am I asking Indigo to stop for a second?
Frog statues need an indication of pushability.
Bingo, because the frog statues need an indication of pushability, right? We can't just assume that they're going to go up and push the frog statues, right? How can we suggest to the player that these frog statues are pushable like the statue that we just pushed?
You can always use some markings on the ground like they've been pushed into that location.
Bingo, I love it. I think that's a great idea. Well, we're going to recycle the exact same texture that we saw on the statue in the previous room, put it on the ground next to the frog. Now we're basically saying to the player, push me. Okay?
Push me. Something interesting actually in Cod 4, there's these bunch of like yellow markings that indicate that object can be interacted with.
Yeah, exactly. Exactly.
And there's an interesting story plot behind it too, but I don't know if I want to say any spoilers.
Okay, good.
Yeah, I'd like to figure out like the scripting for changing a material so that when you mouse
Mhm.
over it and it can be interacted with, it's
It
like
changes.
a line
Mhm.
that changes. I would hopefully add that to all the interactive
Get component renderer, get component dot renderer, and then triangle brackets, the material. Do some research on it. You can figure it out.
So in here you find a chest.
Oh, I just had some legit deja vu. That was weird. Sorry. Okay.
You get an item that lets you hold like oil. I hope that you
Okay.
find like little oil droplets. This will let you collect them for a lantern item that you'll have
Okay.
already before coming to this level. The lantern item will let you light the unlit torches. So these are unlit torches.
And then I'm gonna turn those on.
This door will be shut after you come in. So it'll shut behind you.
Got it. Okay.
You'll have to light these and then it'll open.
So you may want to add, if you go back to the area that where you gain your lantern.
In the first level. Like the
Okay.
open world island.
So in the open world island, you've lit those cauldrons before.
Yeah, I want to have the character give you a lantern and I want to create some more stuff like that.
Okay.
Level's totally not finished for me.
Okay.
So, this is the same thing where
You light it.
this like key will drop,
Okay.
which will be key
Now,
that
you know
unlocks this door.
what you could do to get the key to make it a little bit more a little bit more of a challenge is to combine both of the challenges that you've already had, right? Because you have a push challenge and then you also have a lantern lighting challenge. What if you need to push a whole bunch of blocks to get to the last lantern which you lit that gives you your key? Time it too. That could be cool too. Yeah, you can start combining these experiences to make it, you know, kind of twist it a little bit, so that you're creating something new from components that you've already created and established.
Yeah, like maybe this room is figuring out the push thing.
Yeah, that could be a cool idea.
Would that would that confuse the player too much though? Because they might feel like, oh, I'm supposed to do something here, or do you think they just come back and?
Yeah.
Maybe if,
Because you can't light it until you get the.
yeah, so maybe if you were to have like a thing that is covering it, like a shrub fest, that you would have to light to burn away. As a possibility.
Yeah, that could be a cool way, or have that cauldron like up high somewhere, right? Like up at the top. Okay, you don't get the key, and you got to push a whole bunch of blocks in a very specific set to get up to that thing, right?
Maybe make like a rope, and then like the moment the fire axe touches the middle, it ignites all the way to the rope.
That's a cool idea.
So the next part, there's several things I think that need that at this level, like little more details.
Okay.
So you come into this room,
Right. So once we get the key, you come into this room.
and that door over there is locked.
Okay.
So when you light these torches, that door just automatically.
Now I didn't even notice. If you hadn't told me there's a door over there, I wouldn't have said that there's a door over there.
Yeah.
Right. So because if you go back in,
Yeah, right here,
uh-huh.
impact. So
Okay.
I feel like you're gonna be stuck in here.
So you're gonna wander around for a bit
Wander around for a bit until you figure out.
until oh, there's a door over here. Okay.
Also, hopefully door opening and closing would make a sound. So
Okay.
I hope that you might be curious and light these torches and hear door opening sound.
Okay.
I mean, that kind of makes sense that you'd find the door if you walk up to that thing, you see the vine doors, there's still a path leading off to the right. And then as you approach that, you'll notice the door.
This is another pushable block.
Is that a toad, by the way?
Yeah,
That's-
it's a toad or a frog.
I love it. I think it's just cool.
Yeah, it's a little lily pad.
Cool idea. Door opens when a frog statue hits the bottom of the water. Okay.
And then you'll light this torch and key will drop.
Okay.
And I think, whoa.
That was cool.
Used to unlock this door.
Okay.
Is water death in this?
Yeah, I want you to, well, maybe not death, but respawn back on
Yeah.
the layer.
Which is like, when you said like that, we were talking about the frog statue, my first inclination would be, okay, there's a statue right here, jump in the water, and if it is just a respawn, you learn that that's not the right way, and then
Yeah.
push the statue, so.
This will be some kind of weapon that will let you cut things. And
Da-na-na-na. And then you can go back up to the door with the
yeah, with the block.
with the vines. Cut the vines open. Okay. Cool.
So you cut vines and come in here, and you encounter enemies, which these are just representations.
It's awesome. This is like I'm having nostalgia here. This is like a 3D version of Dragon Warrior for me with the ooze and this. You guys ever played Dragon Warrior from the 80s, Nintendo? Yeah, maybe a little bit before your time.
So
Anyways,
I want the player to be able to make a decision whether they want to push this, which I've indicated by
yep,
that ground.
Yep.
Which I want to implement in the other room, but haven't yet.
okay,
So you can either push this, or decide to go around this way.
fight your way.
Also push this.
Okay,
Or keep going around to fight the
Okay.
enemies.
cool.
Push this all the way this way, and come around this way to avoid fighting those other two enemies.
Sneak in the back
This
door.
enemy holds the boss key, so
Okay,
kill him, get the boss key, and this is the boss key door.
okay. And then oh,
Maybe a tricky one that I want to figure out ways to make it more obvious. I want you to light these torches
okay,
in order to damage or scare this enemy.
all right.
So I want him to kind of like the darkness, and when you light a torch, he moves
Like
away from it.
flinches or something. Yeah.
he
Okay.
won't like it, and you'll use your weapon to kill it,
Okay.
and that'll be the end of the level.
All right.
That last part kind of reminds me of Zelda: A Link to the Past, when you fight Ganon, because he gets rid of the light and becomes invisible, you can't even see him. But when you turn on the lights, you have the ability to then attack him.
Maybe add like some spikes to the little front of the boss. Like add variation that is different from the other.
Oh, these guys are just placeholders. These won't actually be the enemies.
Yeah, but when you do work on your last boss, I would imagine a particle effect, like a shadowy particle effect that would, you know, dissipate when you have all the lights on. So then it would be kind of clear that he's the darkness and that light is the weakness.
Yeah, and I want him to move away. Like if you light a torch over here, I want him to run away to the opposite side of the room.
Maybe you can only have 2 torches lit beforehand.
Yeah, two of them to be lit, like here, here, Sylvia at the back, maybe. That's it so far.
Awesome. Well, it's looking really good, Indigo. Let's give her a hand. Great job. I like it. There's some good stuff in there. All right. Who else wants to share what they've created? Nobody. Bum bum bum.
Pacifist route you can take, but you still have to get the box, so you
You
still
have to fight one.
you have to fight one.
Yeah.
That's not very Undertale.
All right. This week for our homework, you got, there's actually homework this week. You're welcome. This week for our homework, we need to get our levels kind of to a final art level pretty fast, okay? We spent the last couple weeks prototyping and gray boxing. I hope that you spent some time over the last 7 days really getting into a spot that it is meeting all of our design oh, and I apparently did not activate that week 6 module. I apologize. But this week, we're final art assets for your level, okay? So very similar to what Indigo has done for hers. She's ahead of things a little bit. We want to get to a point where we can actually start to see a direct representation of what this is going to look like, okay? Because from there, now that we have a good solid feeling of the spatial relationships between all the objects in the scene, we can now zero in and start looking at all the scripting components and getting all those challenges and the interactivity at the least start to be conceptualized when it comes to code. Okay, so that's our big goal this week. Let me activate it real fast.
When you say final, do you mean like final with quotations around it? Like,
I'm sorry, I couldn't hear you.
when you say final, do you mean like final with quotes around it, like just make more progress, or?
Yeah, you get it to, its final form, as close to your final form as you can make it, right? We should be seeing, at this point, we should be, at the very least, be having something that's representative of what's going to end up in the final game. All right, let me activate the modules and stuff real fast. I apologize. All right, if you refresh your page, and I'll do the same over here, week 6 pops in. Yep, okay. So, final art assets, okay? We've been gray boxing for a while. Now you gotta start making some decisions, right? Idea time is done. Now it's time for execution of your battle plan, okay? Spend some time in Modo or however it is that you're building these art assets, okay? Put some rough textures on there. If you look at the texturing work that Indigo had done in hers, I think that's a really, really, really great direction to head in. Not everything is custom like Substance Painter texture. She's using a lot of really great tiling textures in there, and it looks awesome, okay? This is as hard as we make it. Try to think in the idea of modularity. Instead of trying to make everything a custom piece, are there places where we can be a little bit more efficient? Make one wall that we then can duplicate in Unity a couple times to create a much larger landscape. We're almost kind of returning to the ideas that we initially began with our grade boxing exercises, using basic shapes. But now those basic shapes have more interior detail in them that can be used in a lot of creative capacities. Okay? So spend some time this week really kind of getting the art finished. Because then, once the art is finished, we can put all hands on deck when it comes to getting the interactivity. And that's going to be the next big element in this, okay? Because, starting next week, I'm going to start requiring you guys to start going in and doing some scripting, okay? And it's going to be part of the weekly builds that you submit. Okay, so prepare yourself. It's going to happen very, very, very soon. Okay? Questions on what we're striving to accomplish over the next 7 days? Everyone good? Everyone feeling it? Generally understanding? If you are behind, you need to catch up very quickly, as fast as humanly possible, because we're not going to stop. Sound good? All right, let's get to work. We've got about 45 minutes in class. Let's hit it.